Okay, we're at the top of page 2 of lesson 7.2. So a geometric series is the sum of the terms in a geometric sequence. So for example, -3, 6, -12, 24, that's a geometric sequence. The common ratio is -2. If you add those numbers together, so -3 plus 6 minus 12 plus 24, so on and so forth, that gives you a geometric series. There's just one formula for the sum of the terms in a geometric series, and that is Sn equals a bracket r to the power of n minus 1 divided by r minus 1. And the restriction on this, if you remember all the way back from Unit 1, rational expressions, r can't equal 1 because otherwise you would be dividing your expression by 0. If r does equal 1, then your sequence would just be a plus so on and so forth. Okay, oops, sorry, I just wrote that one. In which case, you would just get the sum of the first n terms as a times n. All right. So, next example. Determine the sum of the first 10 terms of the geometric series with a equals 5 and r equals 4. Substitute everything you know into your formula. Okay, and simplify. And your final answer should be 1,747,625. It's a big number. All right, let's try the next example. Determine the sum of each geometric series. The first term is 32. The last term, you know, is 1 over 8. That's where the sequence ends. The common ratio is half. So you're going to need to figure out how many terms there are in this sequence first. Sorry. So this is Tn equals ARn minus 1. Plug in 1 over 8 for Tn. Plug in 32 for A, half for R. Okay. Divide both sides by 32. 1 over 256 equals half to the power of n minus 1. 1 over 256 is half to the power of 8. You were using equal basis, remember from Unit 4. So 8 equals n minus 1, so n is equal to 9. So there are 9 terms in this series. Now you can use the sum formula and plug in everything you know. And you should end up getting 511 over 8. Try the next example on your own. Pause the video and then come back when you're done. All right, the sum of the first 6 terms, for example B, is -182. And over here, this was the sum of the first 9 terms. All right, last example. Determine the number of terms in a geometric series if the sum is -63. So Sn equals -63. The ratio is -2. R equals -2. And the first term is 3, so A equals 3. All right, let's plug in everything we know. Sorry. Okay, multiply both sides by -3. And we also need to divide both sides by 3. 63 equals -2 in brackets to the power of n minus 1. Move the -1 to the other side. So you get 64, which could be rewritten as -2 to the power of 6. So therefore, n equals 6, and there are 6 terms in this series. And that's it.